today we're talking about exponential. This is an example of one that in today's change looking at this, oh, that's bigger than 1, so it's going to be growth. Nope. 3 to the negative 1 power is actually 1/3. And that, when you write it that way, it's much easier to see that that one is not growth, that's decay. Then I suggest students write it as a 1 plus or minus something, and in this case it'd be 1 minus 2/3, and that would show me that it's 67% decay. Do another something like that. This time let's do it for a population. Let's say we're talking about the population of sandhill cranes. They're an endangered species, and let's say that we only have 1,000 of them in Minnesota. Let's say that their population is down about 4%. Whatever you place it at. 1,000 sandhill cranes going down by 4%. Not all endangered species, though, are going down. Some of them have actually thrived recently. Generally speaking, the wolves in Minnesota thrived. They introduced a few wolf packs a while ago and kind of let them run free, and full growth generally recently. But they've been having fantastic growth in the wolf population. Does that mean everywhere there's lots of wolves? No. But in general, in the states, it's gone up. There's example, Isle Royals is an example in Lake Superior, where there's actually been a decline in the number of wolves for some reason. I don't know why. There's only 2 wolves left on the island. Whether they're breeding pairs, so you can't get a lot of them. But they're thinking about reintroducing them there and having it, kind of a do-over. So anyway, bottom line, there's a lot of real-life examples of this problem. Okay, so let's say we have 1,000 sandhill cranes, and you should have said 1 minus 0.4 that? Okay, here's another one. Given to you, given to you, let's say we have 23 of whatever it is we're starting with. And then it does this. Careful. Is it growth or decay? Rewrite the problem so that it's clear that it's growth or decay. But in the parentheses, 1 plus something or 1 minus. That's what I was looking for. There's one percent of my room to say. Yep. Yeah. Yep. That doesn't add up to too much more. Yes. Yes. That doesn't add up to the right thing. You want it to add up? You're not a 1 minute. Why is it 1 minute? Because that 1/2 is going to put you in the negative power. So I'm going to do the first rewrite. Start like this. 23 to the, that negative right there just means flip this over to become 2. But then that's not what I said to do. I said write it as a 1 plus or 1 minus something. Final answer, many of you had it already. 1 plus 1. Again, common misconception. Say, oh, you multiplied by 2, so it went up 200%. Multiplied by 2, it went up 100%. Multiplying by the 1, it's brought back to the original. It's only the extra above the 1 that makes it grow. That's 100%. Alright, so a typical question today has a few parts. The first is, can you generally sketch it? If you have this situation, you get a start point, and then you get that it cuts in half each cycle, and it could be in years or months or days or whatever it is, but I'm going to say it's in years. So that you had 5, it goes down half. You get that is decay. Generally, all you have to know for your decay is that they generally look like that. And your growth ones, that would be more like this. That one's growing by 25%. And that might look something like this. The start value on this one, 5. The start value on this one, 5. This one's growing. It's going up, but that's more than 1. This one, if I wrote it as 1 minus 1/2, like I said, you get that we can use these things just like any parent function. If I wanted to take a function like this, going down by 25%, and make it move to the right 3 spots, I just have to go like that. I take the whole graph and move it right 3. So, the function's meant to be like plus 5 on the outside. Where's it going to go now? Upside. What if I throw a negative on the inside? Actually, it's inside by the x is the thing you got to understand. Don't throw a negative in there, you never do. But if you want to have it flipped, you throw a negative there. That flips it left, right. On the inside, it's horizontal on the inside, high, vertical, the vertical on the outside. Outside also. That's a vertical shift of 5. This would be a horizontal reflection. Alright, so if this is a parent graph of decay going down whatever percent, say it starts at 8, goes down by 25%, and then I do this to it, minus 8, guess where it's going down. You know where the thing was in the first place, I already picked where it was here. So it goes down 8. I don't know how far 8 is. You get that? This distance right here, that's 8. So that's as far I have to move down. Grab my red one here, move down, that's far, and go right to 0 now. Does that make sense to you? Okay. Alright, so there's the shifting them, left, right, up, down, that's fairly easy part. Hardest part for today is reminding you how, like, domain and range and those kind of things work. Okay, so here I've got this graph. I'll rewrite it. And it's all the same color as black. Perfect. There's this graph of. Did you know that there's an asymptote on this thing? Do you think there's one or is there 2? How about this? If it's populations, like the populations of white rhino, I just saw this on the front cover of Time magazine or one of those magazines, CNN, something like that. And you rhino that's being guarded 24 hours a day because it's the last white rhino. There's one male left, 2 females, only 1 male, and obviously if you don't have a male, you're not going to keep the population. They have him under a 24-hour guard with guys with guns. Why? Because the reason that rhinos are all now is because of something just stupid. In China, a lot of people believe that rhino thorn will cure you of cancer. And it does not cure cancer. Otherwise, farming rhinos are crazy because, lots of people with cancer, we love to utilize them. Like the word does work. So the point is, they've got down to 1 white rhino and 1 male. And I get how it happens because if you really believe it causes cure cancer, they fail out for it. People fail up. In fact, even the most expensive commodity, it is more expensive than platinum, more expensive than diamond for its weight. Because it's just a powder. Okay, so commodity in the world. Running around on 4 legs, and all these people have to do is run over, shoot one, saw off the horn, run away. And they have all of a sudden, compared to where they live and how much money they can make like 100 times what they would ever make for the rest of their life by doing that one thing. So, how that would work. If there was something running around in the United States that you could go kill one and, cut off part of it and get, what would that be comparable for the United States? Probably $10 million. You think they'd have to guard them? Oh, yeah. Okay, so anyway, there's an asymptote here because theoretically the population, if you keep cutting it down like 4% each time, will never go below 0. But and in fact, it shouldn't even touch 0. But in the real world, when you are down to the last one, it should have down to 0. Alright, so there's an asymptote that runs that way on all these graphs. Same thing for growth. You might think that growth wouldn't need an asymptote like that, but if it was a growth graph, it would look kind of like this, and it needs the asymptote for the other end. The other end of the graph gets closer and closer to 0, but never touches. Okay? So whether it's growth or decay, you have a horizontal asymptote of 0. So what does that mean about the right end? Well, it depends. For the black one, okay, the right end gets closer and closer to 0. For the green one, which is growth, the right end gets closer and closer to our left end. The green one on the left end, the green one gets closer and closer to 0, and the black one on the left end gets closer and closer to infinity. How do we describe those? With those. So you get back to those things. Actually, it should be your happy place. I mean, I know you may think of it as like, oh, that's really hard. It's actually extremely easy. Because you always write that on every single problem. The limit function, the vector function, whatever. And you only have to put in 2 little numbers to finish. Okay, so let's say I'm doing the green one, which is growth. And I'd like you to tell me the left hand limit, the right hand. The left hand gets really goes really, really far that way. The right end limit would be, of course, we can go really, really far that way. Okay. Just have it. Left or right? Okay. Left hand, the limit is f of x. X approaches negative infinity. You are correct. It's going way this way. Then the y value when you get there would be 1. Because it's closer and closer and closer to 0 than never left that way. On the right side, x approaches, yep, and what will the y value be, which is over here, when you get there? Yep. Alright. Now let's talk domain and range, that green one. Domain means how far left and how far right does this green graph go. It goes forever to the left, and how about to the right? It keeps going to the right. Granted, it keeps going up, but it also keeps going to the right forever. So this is domain, negative infinity, positive infinity. How about range? Is it unlimited in both directions? No. What's the lowest it can go? Won't ever get there. 0. The highest it can go? The range of this stuff is 0. Alright, so that's pretty much everything we need to know. So let's do a couple of your problems together here. Everything's fine in the worksheet. Pause for a second. Okay, so I don't know where I left off, but now we are starting our worksheet. So try to get for those who join us tonight. This problem's pretty here. We've rewritten 3 to the negative second as 1/9. Why? Because 3 squared would be 9. And then that negative on the power flips 1/9. Now I hope you can see that that's decay. If it's 1/9, that's really small. It's way less than 1, right? So couldn't I write this as 1 for a starting value, and then 1/9 could be rewritten as a 1 minus 8/9. Why am I doing this? Because then I can easily tell what its growth or decay factor is. Its decay of 8/9. In case you haven't done this in the calculator lately, 8/9 is, you done there, though? Okay, 8/9 is 0.88888.8. 7/9 is 0.7. Okay, so 8/9 is 0.8. So this is like 1 for 30 guys, 1 minus 0.88888, etc. And so what's the decay rate? graph. That's the thing that makes you know it is the case. Lower than 1. Okay. Alright, then it says use limits to describe its end behavior. Well, for me, I want a picture of it. A times decay is going to default to the growth graph. Off. Now, the limit on the left end looks like me on the left end. The right end looks close. The limit on the left end is infinity. The limit on the right end, where I guess it looks infinity, is out one of those. The limit of the function as x approaches infinity is okay. Here's another one that a lot of times it's got 0.75, but it's negative 1. Would you agree that 0.75 is important? Since this has no starting number, there's a 1 there. So the starting value is 1. Do you get 3/4 to the negative 1? It's really not 3/4? Yes. 1/3. That's a third. And now I did the negative 1, so it's gone. Because it's x. Now it's you've got to be able to handle these powers of negative 1. All they're doing is flipping it. Once you got it flipped, then you can judge. Bigger or less than 1. Change it into 1 plus something or 1 minus something. 4/3 would be like 1 plus 1/3. So now I know what to say. Okay. Then the last part of the worksheet, there's a few you can skip in here. We're going to skip 16 and 17. A lot of them in here they aren't nearly as involved as one. And here all you got to do is know how to change it from this to this. Like here, first one. There's a -3 after the x. In by the x, inside, horizontal thing. Left or right 3. Right 3. There we go. And then sketch it. Okay, you know what the x looks like? Again, not 50 on exactly. That's generally what growth looks like. And now I have to do that -3 thing to it, which means it was here. Now I got to do -3 on the inside. That means right here. I moved it right 3. Kind of hard to tell, but if I leave the original up there, it'll have the black one. Okay. Next one, 4 to the x. That's growth. Generally looks like this. And now, what happens when I do that on the inside? Horizontal on the inside, but the horizontal left. Reflection. Horizontal means left, right, like this, kind of a reflection. Can you picture that red line would change to that green line? You get that every time you see a negative up in the top, flipping the graph around from growth to decay. If you take growth and you flip it, the red one's growth, but you flip it left, right, and it's decay. That's why the negatives and the exponents are so important, because you see one there, it means it takes whatever it was going to be, and it flips it. It was growth, now it's decay. It was decay, now it's growth. Alright, let's sketch my graph, but I never said what I did. Describe how to transform it. That was a horizontal reflect. Okay, when you get to number 11, for instance, you got two things going on. Here's the parent one, so parent decay starts. Then it gets 3 times taller. Start value changes from 1, which was the imaginary number of 24, to a 3, so it's 3 times taller. And what's that plus 4? like this. And now I got to make it 3 times taller and up 4. Okay, giving you as much help as I think I should. So, got the rest of the time to work on this again. Last couple of multiple choice and review. Super easy, should be anyway. But I want to remind you of one thing you learned yesterday that I want to make sure you get. Yesterday, you were doing problems where we give you a line like that, and they'd say, okay, it started at 8, and so this is 0, 8, and then it went, let's say this is 8, 3. You have 2 points to be able to write the equation for. 2-second reminder of how that works. Y equals a b to the x. That tells me start value is 1. Okay, you're not listening. Pay attention. I'm going to make you check your iPad. Are you with me, please? I circled it even. What's the start value? 8. Okay, if it's 8, then a is 8. Okay, now I need to figure out how do I do that? Putting in 7. So if I'm going to put in that other point of 8, 3, x is 8, y is 3. Here's an 8. Here's a 3. Now I got a little equation to solve. 3 equals 8 times 3 equals 8. What's the first step? Divide by 8. That's gone now. Now is b alone yet? Put it to the power of 8. 1 8. Put it to the 1 8. Good. B's alone. Found b is that. Y equals a b to the x. We now know a is 8. We now know b is that weird thing. What? 3/8 to the 1/8. So that's 1/8 x. Bring that up here. 3/8 to the 1/8, and we have to have an x in the exponent, right? And the x would be on top. So 1/8 x. What you should have learned yesterday. I really believe in review. By testing it there, I think you make it for like 3 more days remembering that thing. That's the mind that you thought it probably your short-term memory was. Okay. So now you've got, the video is 22 minutes long, but I know there's a little gap in there. You've got 3 minutes left. So, you guys have some time to work. Please utilize it as a course during that time. If you had a bad one, you can say to yourself, don't do it again. Just get one free one, it gets wiped out every quarter. And you drop your lowest score. If you have a lowest one, yeah, that's what drop your lowest score. Then do it again. You have one bad one, don't worry about it. But shall keep doing it. Shall learn to read it.